Next example is if the slope of one of the lines given by ax square plus 2h xy plus by square equal to 0 is square of the other. Then show that a square b plus ab square plus 8h cube is equal to 6abh. Here the relation between slopes, slope of one of the line is square the slope of other, slope of one is square the other, that is m1 is equal to m2 square or m2 is equal to m1 square. कोणती एक कंडिशन घ्या. Now here given equation ax square plus 2hxy plus by square equal to 0, it is equation number 1. Let m1 and m2 are slopes of lines 1. Okay. Here m1 and m2 are the slopes of line represented by this equation. Therefore we know that m1 plus m2 is equal to minus 2h by b and m1 into m2 is equal to a by b. And given that slope of one of the line is square the slope of other, given that m1 is equal to m2 square, m1 is equal to m2 square. Okay, now then these three relations are the given, m1 plus m2, m1 into m2 and m1 is equal to m2 square. Then we want to prove that a square b plus ab square plus 8h cube equal to 6abh. Okay, now m1 plus m2 is equal to minus 2h by b, m1 into m2 is equal to a by b. Here we want here highest, it is 8h cube, h cube and it is h here. Therefore taking cube of this term, therefore we can write m1 plus m2 is equal to minus 2h by b. Taking cube of this term, m1 plus m2 cube is equal to minus 2h by b cube. Taking cube of this term. Then here m1 into m2 whole cube, here a plus b whole cube expansion, it is a cube plus 3a square b plus 3a b square and plus b cube, it is the expansion of a plus b whole cube. Therefore m1 plus m2 cube, therefore this can be written as m1 cube plus 3 m1 square into m2 plus 3 m1 into m2 square plus m2 cube is equal to minus 8 h cube by b cube. Okay, it is cube of minus 2h upon b, it is a. But we know that the value of m1 into m2, m1 plus m2 and m1 is equal to m2 square. Therefore this m cube can be written as in the form of here m1 into m2 square, sorry, it is m1 square, m1 into m1 square, it is m1 cube. Then 3 m1 m2 take common, 3 m1 m2, then it is m2 plus m1, it is m1 plus m2. Here 3 m1 m2, 3 m1 m2 take common, here remaining m1 and here remaining m2. Again m2 cube can be written as m2 into m2 square, and it is as it is, minus 8 h cube upon b cube. Now here m1 is equal to m2 square, therefore we can write m2 square into m1 square plus 3 m1 m2 into m1 plus m2 plus m2 into m2 square, and it is m2 square is m1, therefore m2 into m1 is equal to minus 8 h cube by b cube. Okay, now here see carefully this term, here m1 is equal to m2 square, it is m2 square and is m1 square as it is, and in third term here m2 into m2 square, the m2 square it is m1. Now it is m2 m1 whole square, that is m1 into m2 whole square, m1 into m2 is equal to a by b, 3 m1 m2 it is a by b, m1 plus m2 minus 2h by b, and m1 into m2 again it is a by b. Put the all values of m1 m2 here, therefore it is a by b square, it is m1 m2 whole square, m1 into m2 it is a by b, plus 3 a by b into minus 2h by b, it is m1 into m2 and m1 plus m2 plus a by b, and is equal to minus 8h cube upon b cube. Now calculate. Okay, here therefore a square upon b square minus 6ah upon b square minus 6ah and upon b square plus a upon b is equal to minus 8h cube upon b cube, throughout multiplying by b cube. Therefore we can write here a square b multiply by b cube, b square cancel, here b remaining, again here b square cancel, b remaining, minus 6abh plus ab square and is equal to minus 8h cube. Okay, and it is the proof. Now this proof can be written as in the form of this, minus 8h cube या side लगा, minus 6abh या side लगा, then a square b plus a b square plus 8h cube is equal to 6abh. Okay, it is the last answer. It is the proof. Okay, see carefully, we use here a plus b whole cube expansion and three relation m1 plus m2, m1 into m2, and it is given in the problem m1 is equal to 2 m2 sorry m1 is equal to m2 square. Okay, now next example. Prove that the product of lengths of perpendiculars drawn from point P x1 comma y1 to the line to the lines represented by ax square plus 2hxy plus by square equal to 0 is mod of ax1 square plus 2h x1 y1 plus by1 square upon under root of a minus b whole square plus 4h square. It is the product of length of perpendicular. Okay, here given line ax square plus 2hxy plus by square equal to 0. It is equation number 1. Now let m1 and m2 are slopes of lines 1. Okay, m1 and m2 are the slopes of lines represented by this equation. Therefore we know that m1 plus m2 is equal to minus 2h by b and m1 into m2 is equal to a by b. Okay, are the given condition. Now here we find the product of length of perpendicular drawn from the point to the line. Okay, here this equation represents two lines. Okay, first we find the separate equations. Therefore here y is equal to m1x and y is equal to m2x are separate equations of 1. Here m1 and m2 are the slopes of two lines represented by this equation. Therefore m1 and m2 are the slopes of two lines passing through origin. Therefore the equations of lines is y is equal to m1x and y is equal to m2x are the separate equations of the line 1. That is, these equations are here m1x minus y equal to 0 and second equation it is m2x minus y equal to 0 are the equation of line. Now we find the product of length of perpendicular from point x1 comma y1 to the line m1x minus y equal to 0 and m2x minus y equal to 0. Now let it is given, it is let given point it is x1 comma y1, let p1 and p2 are the length of perpendiculars drawn from P x1 comma y1 to m1x minus y equal to 0 and m2x minus y equal to 0 respectively. Okay, now we know that the length of perpendicular, suppose it is a point x1 comma y1 and it is a line ax plus by plus c equal to 0, then the length of perpendicular drawn from the point, it is suppose P. Therefore, length of perpendicular P is equal to, it is ax1 plus by1 plus c upon under root of a square plus b square. Okay. It is the length of perpendicular, under root of a square plus b square. Here it is a point and it is a line, ax1 plus by1 plus c. It is a perpendicular distance of a line from the point. Now we find the perpendicular distance of line from the point. Therefore P1 is equal to, it is mod of line m1 x minus y equal to 0 and point x1 y1. Therefore m1 x1 minus y1 upon under root of, it is a square plus b square. Here a and it is b, that is m1 square and plus minus 1 square. This can be written as it is m1 x1 minus y1 upon under root of m1 square plus 1. It is a P1, that is a first length of perpendicular from the point to the line. Then P2 is length of perpendicular from point to the line, same as m2 x1 minus y1 upon under root of m2 square plus minus 1 square, that is equal to m2 x1, sorry, it is x2 x1 minus y1 upon under root of m2 square plus 1. Here it is P1 and it is P2. Now we find the product of length of perpendicular. Length of perpendicular are P1 and P2. It is P1 by the perpendicular distance formula. It is a perpendicular distance formula. It is P1 and by perpendicular distance formula it is P2. That is line this P2, sorry. It is line and it is point. It is A and B. A and B. It is a perpendicular distance formula. It is perpendicular distance. Now we take the product of this. Here. Now P1 into P2 is equal to mod of m1 x1 minus y1 upon under root m1 square plus 1 into m2 x1 minus y1 upon under root of m2 square plus 1. Now take the product. Here now calculate. It is multiplication, numerator, denominator. Here m1 x1 into m2 x1 and m1 x1 into m1 y1. Therefore we can write here m1 m2 x1 square, m1 x1 m2 x1 minus m1 x1 y1 minus m2 x1 y1 and plus y1 square. It is the multiplication of the numerator, m1 x1 minus y1 and m2 x1 minus y1 upon, here take the multiplication of these two terms in under root. Here m1 square into m2 square plus m1 square plus m2 square and plus 1. It is the multiplication. Only multiply numerator and denominator. Now we know that the values of m1 plus m2 and m1 into m2. Here m1 m2 whole square, here a square by b square, but here m1 square plus m2 square, but we know that only the m1 plus m2. Now see carefully, m1 into m2 x1 square minus, here take x1 y1 common, therefore minus x1 y1 common घेतल्यानंतर here m1 plus m2, x1 y1 plus y1 square and whole to the upon, here under root of first term as it is m1 m2 whole square लिहा किंवा m1 square m2 square plus now this m1 square plus m2 square, m1 square plus m2 square, it is m1 plus m2 whole square minus 2m1 m2, it is, calculate this, we get this value m1 plus m2 whole square minus 2m1 m2. Here we know that the value of m1 plus m2 and m1 into m2, therefore m1 square plus m2 square converted into these two terms and plus 1 as it is. Okay. Now put all values of m1 plus m2 and m1 into m2. m1 into m2, it is a by b, x1 square minus, it is minus 2h by b, x1 y1 plus y1 square whole to the upon in under root, it is a square by b square, m1 into m2 whole square plus minus 2h by b whole square minus 2 into a by b, and it is plus 1. Now only calculation, it is a x1 square upon b plus 2h x1 y1 upon b plus y1 square whole to the upon, here a square upon b square, it is plus 4 h square upon b square, then minus here 2a upon b, this can be written as it is 2ab upon b square, here 2ab upon b square, here denominator converted into same denominator because addition or subtraction will easily done by here, again here plus b square by b square. Okay. Then now we can write, it is same a, 1 minute, it is, yes, a x1 square plus 2h x1 y1 plus b y1 square upon b whole to the upon, throughout here b into y square and throughout upon b, upon again here under root of, now here it is a square minus 2ab plus b square plus 4h square and upon in under root b square. Okay, see carefully, here b ने फक्त multiply केले here b and in denominator in under root a square minus 2ab plus b square and plus 4h and whole to the upon b square in under root, that means it is b and b get cancelled and this term b get cancelled, this term can be written as here a x1 square plus b 2h plus 2h x1 y1 and plus b y1 square whole to the upon, here b square, that is b and b get cancelled, here first three terms are a minus b whole square and plus 4h square, and it is the proof. Okay, see carefully. Okay, calculation carefully here. It is a y is equal to m1x and y is equal to m2x are the separate equations, and then perpendicular distance from point to the lines are the perpendicular distance by perpendicular distance formula, and then we take the product of these two terms, and it is the product. Okay, see carefully. Now next, show that the difference between slopes of lines tan square theta plus cos square theta into x square minus 2xy tan theta plus sin square theta y square is equal to 0 is 2. Okay. Here we find the difference between slopes. It is a second degree homogeneous equation. Here given equation, tan square theta plus cos square theta x square minus 2xy tan theta plus sin square theta into y square is equal to 0. It is equation number 1. Okay. Here compare with ax square plus 2hxy plus by square equal to 0. Now here a is equal to tan square theta plus cos square theta. 2h is equal to minus 2 tan theta, and b is equal to sin square theta. Here we find the difference between slope is equal to 2. That means m1 minus m2 is equal to 2. m1 minus, we show that the m1 minus m2 is equal to 2. That is difference between two slopes. Then we know that the relation between m1 minus m2, m1 plus m2 and m1 into m2. In the last lecture we see the m1 minus m2 whole square is equal to m1 plus m2 whole square minus 4m1 m2. We use this relation. Therefore first find m1 plus m2 and m1 into m2. Let m1 and m2 are slopes of lines 1. Therefore we know that m1 plus m2 is equal to minus 2h by b. Minus 2h by b, it is minus 2 tan theta upon b, that is sin square theta, and then it is 2 tan theta upon sin square theta, and m1 into m2 is equal to a by b. m1 into m2, it is a by b tan square theta plus cos square theta upon sin square theta. Here are the values of m1 plus m2 and m1 into m2. Then we know that m1 minus m2 whole square is equal to m1 plus m2 whole square minus 4 m1 m2. Then put all values of m1 plus m2 and m1 into m2 in this. Therefore we can write m1 plus m2, this 2 tan theta upon sin square theta whole square minus 4, it is tan square theta plus cos square theta upon sin square theta. Okay. Now here only put the values of m1 plus m2 and m1 into m2. Now we calculate. Okay. Then it is 4 tan square theta upon sin to the power 4. Here it is the square of this term. Now minus 4 as it is ले लो, 4 into tan square theta plus cos square theta upon sin square theta. Now convert tan square theta into sin and cos. Therefore it is 4 sin square theta upon cos square theta whole to the upon sin square theta, sin to the power 4 theta, minus it is 4 as it is. Again here convert sin square theta upon cos square theta plus cos square theta and whole to the upon sin square theta. Okay, then here sin square theta and it is sin to the power 4 theta, sin square cancel and it is cos ला खाली. Therefore this can be written as 4 upon sin square theta into cos square theta minus it is 4 into, again take the addition, it is sin square theta plus cos to the power 4 theta upon cos square theta and upon sin square theta. Therefore it is sin square theta into cos square theta. Now here denominator is same. Therefore take subtraction. Therefore 4 minus 4 sin square theta minus 4 cos to the power 4 theta upon it is sin square theta into cos square theta. Okay, here it is denominator is same. Now here 4 get 4 4 4 take a common. Now 4 into 1 minus sin square theta minus cos to the power 4 theta whole to the upon sin square theta into cos square theta. Again it is 4 into 1 minus sin square theta, it is cos square theta minus it is cos to the power 4 theta whole to the upon sin square theta into cos square theta. Again take cos square common. 4 into cos square theta into 1 minus cos square theta upon sin square theta into cos square theta. And now cos square cancel, 1 minus cos square and it is sin square get cancel, it is only 4. Therefore m1 minus m2 whole square is equal to 4, and that is difference between slopes is equal to 2. m1 minus m2 whole square is equal to 4. Therefore difference between, that is mod of m1 minus m2 is equal to 2. Therefore the difference between slopes of the lines represented by this, it is 2. See carefully. Now next example in next lecture.